guys, I have to tell you that the erosion of Mars is absolutely insane. And I don't know if it was from water or some other fluid, but there is definitely evidence of massive movements of fluid across the surface of Mars. Now, you probably think the Valles Marineris, the largest canyon in the entire solar system, is the most impressive erosional feature on Mars. But in my book, it's not even close to what's on the North Pole. When you realize exactly what this is, it will blow your mind. But first, let's understand the erosional makeup of most of Mars' surface. It has many straight channels in close proximity. Now, the general rule is that the straighter the river channel, the faster the current was moving. So a high density of straight river channels is perfect evidence of sheet water flow. Now, the Giant Canyon is also a straight channel with another straight channel parallel to it. Smaller channels flow into it and from it. They show fluid movement of large sweeping paths. Narrow and deep ruts are consistent with a heavy fluid, like water, or perhaps something even heavier. There are ripples all over, and they tend to be in the canyons. It's too bad I have no way of measuring them, but just know they are massive and catastrophic. But now, let's get close to the North Pole, where a vast ripple field is found that bears quite a striking resemblance to the Sahara Desert, with both ripples and drumlin forms. These distinct edges show where the current ran across, forming the edge like a riverbank. Now it's time to study the most catastrophic feature on this planet, the ripple swirl of the North Pole. Yep, that's exactly what this is. The whole planet shows evidence of sheet water flow. Now, if the atmospheric currents were driving this, then we need to think in terms of the Coriolis effect. The most powerful convection cells are the polar ones. That's why it's violently windy and the seas are the most treacherous near the poles. These cells drive a current that spirals radially from the pole center. And that's exactly what this spiral ripple pattern is depicting. This entire convection cell made one ripple formation, showing exactly the movement of the cell. Now that's a catastrophe. And now these ripples are frozen in ice caps, perhaps even the same fluid that they were formed from. There is a ripple formation on the North Pole of Mars that could only form from a spinning current of heavy fluid, and this area was once under its ancient ocean. Now, I originally thought that it must have been driven by the polar easterlies, but after some more research, I think it was actually from a polar vortex. They seem very similar, but they are actually very different. The polar easterlies are surface winds that are a part of a convection cell. They spin to the east due to the planet rotating underneath them as they travel southward. But a polar vortex is in the stratosphere, 3 to 10 miles from the surface, and it doesn't spin due to the Coriolis effect. Instead, it is driven by temperature-caused pressure differences. Because this drives it, they can spin with or against the planet's rotation. Earth's polar vortex usually spins against it. But these polar vortices can be very messy, and they almost always have a minor vortex attached to them that spins in the opposite direction. I actually captured this type of motion when a river current collided with an ocean wave. The stratosphere behaves the same way when its currents collide. So when a polar vortex reverses, it's just when the minor vortex outgrows the major one, so it's not a big deal. Now let's go back to Mars. The major vortex is easy to spot. Its eye was at the center of this ripple formation, which is exactly centered around the true north of Mars. We know this was the center because ripples tend to form perpendicular to a current. Okay, so where's the minor vortex? I'll let you take a moment. Its center was right about here. This is indicated based upon this massive berm of its perimeter, just like how this river example also makes a berm. So it's likely that its eye traveled like this to make such a berm shape. When we zoom in, we find ripples perpendicular to the berm in several places. And then we can find drumlins parallel with the berm. These are the two main features of fluid motion, and they both agree with the current of the minor vortex running along the berm. Now there's a few other notable berms on this North Pole. But we can also see from this photo that there's a whole circular berm on the entire North Pole of Mars. That's from when the polar vortex dominated and there was barely a minor vortex. I would suggest that the polar vortex moved water currents on the planet, since water is so much more capable of forming huge features compared to less dense gases. There was a much smaller ocean on the South Pole of Mars, and that is why the ripple formation of the South Pole is much smaller than that of the North Pole, and doesn't have any large berms.